Alright, how's it going? I'm going to try a little bit of a different video today. We're going to try and do a little tutorial if you're thinking about 3D printing or 3D design. I thought I'd do this every day, design stuff and 3D print stuff, and I thought it'd be good to put up a tutorial because I have utilised YouTube a lot and got free knowledge off there, and I thought it was only right to put some knowledge of my own up there. So this will be more of a beginner's one and a very probably rough as my first video. Run through using the software and that, so we'll see how it goes. What I'll start with, what I'm going to design, I'll show you a video. Let's move my screen a little bit. I took a little bit of video here about how the part gets used. So this is for my own shop, and I got this, it's called Racket racking. I'll just go back a little bit. So that's all my 3D printers are on this Racket shelving. It's adjustable height, and you can get all additions and stuff for it. Really good stuff. We get it from Bunnings. I don't know if they sell it anywhere else, but it's called Racket, and it's very good stuff. And you can get this pegboard, which clips into the racking. Very useful, but of course you're limited to just what pegboard tools and shelves and hooks that they can provide. So I've 3D printed and designed customized tool holders for all sorts of bits and bobs, and I've been printing more and more to try and get a range up there on the my website. If you want to go to it, it's macparts3d.com.au is an online shop. All the parts are on there. But anyway, so let's just go through. It's got the little tape dispenser, glue stick for pen holder, the text, I'll show you how to put that on there. Holds a scraper, scissors, snips, bolt cutters. So yeah, and I'm just going to try design for as many different applications as possible. This is what the part looks like. Hooks in at the top, and then the bottom has some push plugs that just sort of locate in the pegboard. So that's what it is, and I'm going to design another one tonight, so I'll get rid of that, and I'll leave that to the side for now. And this is what we're going to look at doing tonight. This is one of the parts. So this is for the scraper, designed for, I haven't got the scraper on me, but for a scraper to drop in here. And it's just got the hooks on the back. It's a pretty rough print. When I'm prototyping, I just try to print it quick, and I don't clean it up much. And once it works and I'm happy that I'm going to use it, I'll print a finer copy of it and whatnot. So that's what it looks like. And so I use a feeler gauge. Now, if you do use 3D printers, you'll know what this is for. People use paper sometimes to set their nozzle height, but I have found this is a 0.075 millimeter feeler gauge. I found that's perfect for 0.2, 0.4 and 0.6 mil nozzles, and that's worked really well. And of course it's firmer than paper, it won't tear, gives you a real firm contact with the nozzle and the bed. So yeah, I'd get some of those off eBay if I were you, but I'm going to design one of these with a pocket to suit the feeler gauge so I can just go to it, grab it, it's on the board ready to go, rather than putting it in the shelf in a little drawer where it is now. I've got to keep fishing around to find it. Alright, so let's go to SolidWorks. This is my design software, and this is another one I've designed for my business cards, just to be held there, and if people come in I can give them one. So we'll use this. I've already saved a copy called feeler gauge holder. Now that's really important. If you're ever designing something, I encourage you, before you start designing, save the copy of the part you're doing, especially if you're copying over another part. I've sometimes gone up to an hour of drafting and either copied over another folder or lost it if the program crashes and I hadn't saved it. So always start by saving it, and save regularly as you go. Alright, so we're going to modify this. I'm not going to go too far, but this is not going to be from the ground level up tutorial on SolidWorks. It's just going to be a bit of a rough idea of how I get a part designed, get measurements off the part, etc. Because I'm just going to be taking the measurements that are already being used for this business card holder and adjust them. Because in essence, it's going to be the same thing. It's just going to be a pushed out section, a boxed out section with a pocket in it like that, which will suit the feeler gauge. So I'm not going to draw it from scratch. And that's a good way to, when you're designing stuff, is have templates of parts and save them, and then it takes away the time you have to do by doing that ground level drafting. Alright, but very quickly, if I scroll right back to the start, first thing I did was draft the pegboard itself. Draft it to scale, every detail, check it out, make sure it's exactly right, and that gives you a good foundation on all the parts I draft are onto this template now. We'll go down. I won't go into too much detail what I did there. Alright, that's where I want to be here. This is the backing plate template, so I've got to get this right. So if we go back over to our part, and it's not very wide, it's only, in terms of width, it's only 12 mil wide, and I think it's going to suit this backing plate size anyway. So we'll copy that, the scraper one, which is 50 millimeters. So we'll go back to SolidWorks. This is 35. I'll do off the center here. So all I have to do is adjust this measure to 25, and it'll make the overall width 50 millimeters, which we got there. That's good. And the height, I've got 30 mil there. I'm just going to check this scraper one. Just go back over here. And what's this scraper one? Because this height seems good. Yeah, it's a bit higher. Can't really see that. 40 millimeters. Usually I'd have verniers, but they're in my truck. 40 mil. So I think 30 mil, it needs to be, because this is quite high and quite heavy. You know what, I could probably go a bit deeper. Yep, I'll go even deeper again. I'm going to go 50 mil deep on the overall height of the backing plate so it supports it, doesn't fall out or anything. So we'll go back across, change this vertical height to 50 mil. And we'll just press rebuild. Yeah, that looks good. All right, now we'll go down. The next, so this is called rolling back. So all these features under here are already designed, but I've just rolled them back to edit these features that are behind them. So as I roll it forward, each of those features will jump in. This is where I designed the hooks and the little plugs in the bottom. I won't go into detail about them. It's my special secret. It took me hours to get the size of these little plugs just right so they'd push through the hole, still push through obviously without breaking, but provide pressure and hold the thing in place firmly when it's there. But anyway, let's keep moving. Cool, so that's a combine. I combined all those parts together, and now a few fillets put on, and we're ready to start building off the backing plate. All right, we need a depth. At the moment, I've got 20 mil deep. I've taken that face and brought it out 20 mil for my business cards, but let's have a look what I need for this feeler gauge. The feeler gauge is, well, it's about 20 mil. That pushes in, but I don't want it to be too tight. I want it to be loose. So 20 mil looks good for the pocket depth, and then you need to add in how much thickness of material you want in front to retain it, which I think 3 mil will be fine. And I encourage you, if you are designing parts to be 3D printed, try and do your design, get it working, and then think. I learned this from Elon Musk. I think he calls delete, delete, delete. Try to remove as much material as you don't need. You don't want it to be weak. You still want it to be strong and useful, but you want to only use the material you need to, because every bit of material you lay in costs money. So I'm going to make it 20, which is for the depth of the feeler gauge, plus 3. And that's a good thing about SolidWorks as well. You can just put in your formulas, 20 plus 3. If you've got stuff that's a bit more complicated than that, obviously. 23 mil deep. And now we're going to roll back the next feature, which is the pocket. Oh no, the text on the front. All right, we've got to edit that. So we've got to right click, edit that sketch, double click on the text, and we'll put in feeler, enter, gauge, tick, and we'll just see what it looks like. And it's a bit high, so I'll just have to go into the sketch. I can just preview it, and I've got 13 mil, excuse me, which is to the top line where the text starts on. So I'm going to bring that down, probably another 10 mil, 23. Yeah, that looks better. You know, you could take the time and get it precise, but that looks good enough for me. All right, so that's good. Let's roll back the next feature, a fillet. Oh, yep, just a fillet on the front. We'll leave that the same. Next feature, the pocket. All right. Now that's too wide. We'll go back to our feeler gauge and we'll figure out the width of the pocket that we need to machine, which is this dimension here. And that's right, it's 15 mil. It looks like it's about, my tape is old, and next time I'll get verniers. It looks like 13 mil, so I'll make it, I don't want it too sloppy, I'll make it 16. Give 3 mil clearance in there just to be safe. So we'll come back across. Again, I like that in SolidWorks you can just sort of click on the feature in the design area and it brings up dimensions which you can edit, or of course you can right click on the feature tree, edit sketch, and then you get your sketch there. So I'm going to not go off the edges this time, delete those measurements, delete, delete. I'm going to right click on this line here, find the midpoint, and I'm going to lock the center of my pocket cutout to that midpoint. Boom. And now when I dimension this width, it'll add it, reduce it equally on both sides. And I can't even remember what 16 mil, so I put that in there. 16 millimeters, bring it equally on both sides. 3 mil from the front and 3 mil from the back. I think that's right. Exit. That looks pretty good. I'll roll this next feature back, some fillets. Yep, and that's good. Fillets all the inside, I think 1 or 2 mil. And that's looking like it's pretty much ready to go. Now what I do is I hide this, get rid of that because I don't want that to be 3D printed. I just want to be left here with the part that I'm going to be 3D printing. And what I might actually do, I know it probably doesn't come through, but I'm just going to delete that body. So insert feature, because I don't need that anymore. Delete body, bodies to delete, that one. Boom. And I'm just left with me part that I need. Now it's probably, I could probably go a bit narrower if I wanted and write on these hooks, but just, I don't know, it looks good. The text fits on there nicely, so I'm going to keep it that width. And all right, let's save it as an STL. So this is at the moment is a SolidWorks part to be read in SolidWorks and some other programs, but it won't be read by the 3D printing software. So you go File, Save As, STL, which is what the 3D print software will read. Save. It'll ask me a question. Yes. All right, for now I can close that down. I'll leave that. I'll open up, this is my slicer software. Plenty of tutorials about how to use the nitty-gritty of slicers on the web. I'm not going to do anything in terms of explaining that, but I just wanted to show you how to cut. I will hopefully in the future show you how to design more and more just custom parts. And I don't use a 3D scanner. I just use measuring tooling, and you can get some pretty good results just with tooling. All right, so we're going to clear the build plate. Go to prepare, open, find my part, which was in downloads for now. There it is, racket feeler gauge. It's the one. Now, when I'm printing stuff like this, obviously the weak point is these little hooks. If you push them in and put a little bit of pressure on them, they're just going to snap off. So if I printed it in this orientation, the layers would print in this sort of direction. And so when it came to printing these, actually let me just do a slice on that and I'll show you the preview. It's going to print in this direction, and at this point here, the layer's only going to go from there to there. And it's going to be very, very weak and most likely snap off very easy. So if you come down, that's where it's going to be printing a layer like that. That'll snap off a piece of cake. So what we'll do instead is, let's go back to repair. We're going to orientate it in, well, we can either do one of two. We can do that direction. So when the layers go down, they now will go in the opposite direction, which will work to support when that's installed into the board and you pull against it, that layer is now going to be a lot stretched over the point, the weakest point, and be a lot stronger. That's one direction you could do it in, like that, or we could do it this way. Same thing. So when it prints, the layers will come from on the body out through the little part and back through the body. Let's have a look. Let's just slice it. So when you're doing parts with little, you want strength, you really got to think about the way the layers go and if it's going to work in the way that your part is going to be used. So have a look at a preview of this. So you can see there that the layers come from out of the main body into the little weaker part and then back into the main body, creating a really strong sort of join. So when you apply pressure on here, maybe when you're trying to get it back out or put it in, and it's not going to just snap through this small round section. That's all tied back into the main body now. So that's really useful. It took me a little while to figure out that and just to have my mindset thought to like which way do my layers go. Now obviously putting it this way means we're going to have the full pocket filled with support, but that's just unavoidable. We'll pluck all that out and give it a little scrape and clean up. That's why I made it a little bit bigger, so there are, a little bit, if the dimensions are a bit smaller, it's not going to be tight on the feeler gauge. I think I will go in that direction purely because if I went the other way, it's got a lot more distance for the support to build to uphold these little bits. I use a little bit of brim, just I don't know. I'm just a sook. All my prints, I'm in a shed here. I just set them and I forget them. I go. I don't monitor them. So I generally put a small brim on there, keep things tight. I watch the first couple of perimeters go down. If they're looking nice and flat and fat, then I just let it go. Feeler gauge, yeah, we're ready to go. All right, so I am going to just make the title a bit shorter because sometimes that can be a pain. Feeler gauge holder. All right, well, I'm literally going to save it to a mini micro USB now, take it over to the printer. I'll print it out tomorrow morning or tomorrow night. I'll show you the part and if it works, and then we might design another part. All right, take it easy.